Good morning, students. So I welcome you in the lecture of digital VLSS circuit design. So in this lecture, we will discuss about the CMOS. So that is nothing but the complementary MOS. That is nothing complementary metal oxide semiconductor. So how and what is exactly this mean by CMOS? So let's start with the video. If you are not subscribed my channel, please go to the subscription. If you are subscribing, then you are getting the latest update of each and every video which I uploaded on my YouTube channel. So please like the session. And if you have not watched the previous video in which we have discussed about how MOSFETs work. If you have not watched the video, so please go through the playlist and you can watch the entire video series of digital VLSI. So we will start with this circuit. So what exactly mean by IC, that is integrated circuit? That is nothing but what? Many transistors, billions of trillions of transistors on a single chip. If you are observing your i7 processor, so near about 64 billions of transistors are there on this single chip. Can you imagine that billions number of transistors on a single chip? So how that they are fabricated on the single chip? Okay, so how they are fabricated? So they are fabricated using the technology called as VLSI. So what exactly mean by metal oxide semiconductor MOS transistor that we have seen in the last lecture? If you have not watched, please go through it. So why we are going for these transistors? Because they are fast, they are cheap, and low power transistors. They are low power. Okay, the power consumption is very very less. Sorry. So what exactly mean by complementary? So complementary is nothing but the mixture of n type material and p leads. Okay, n and p, we are, if you are mixing that one, the combination is called as complementary pair, leads to less power consumption over there. Okay, so we'll start with, so there a MOSFET, there are three kinds of MOSFETs. That is nothing but the NMOS circuit, then PMOS, and the both if you are using, then nothing but the complementary MOS circuit. Means NMOS, that is nothing but the, in this one you are using the N circuit, N channel, I can say that. And in the PMOS you are using the P channel over there, and that is nothing but the metal oxide semiconductor. This is nothing but the MOSFETs. Okay, this is nothing but the MOSFET. N channel MOSFET, I can say that, and P channel MOSFET. If you are combining these two, you are using in a single circuit is called as CMOS. That is nothing but the complementary MOS circuits. Yeah, so we'll go for this. This is nothing but my MOSFET. Okay, so MOSFET, can you comment in the comment box that which MOSFET is this one? Either enhancement MOSFET or depletion MOSFET. Forget about N channel or P channel. This is enhancement MOSFET or depletion MOSFET. If you know the answer, then comment in the comment box. I mean, watching your comments, and I will give the answer. So normally I will give the answer in this video. So this is nothing but my enhancement MOSFET. Okay, why is it so? Because the channel is absent, totally absent over there. The channel is absent over there. That's why it is called as enhancement. In the depletion region, depletion MOSFET, the channel is already present over there. So this is the drain terminal. Yeah, this is the source terminal. Okay, and the gate terminal is connected via oxide layer. So this is, and this is a semiconductor, means substrate you can use over there. Here B, or here B, and the channel from this substrate is nothing but my N. So we are extracting my holes by connecting this gate to the positive supply or negative supply. So electron holes will get here over, and they are forming the layer over there. Okay, so this MOSFET, this is nothing but my MOSFET over there. The source is of phosphorus or boron. We can use phosphorus or boron, and drain is of again phosphorus and boron. Why is it so? Why is it so? Because we know that in case of semi-silic p-type material. Okay, p-type material, so we are, what we are doing in this one, we are using either boron, or we can say that either phosphorus. That is nothing but for p-type metal. P-type metal we are using what? That is nothing but we are using boron, indium, or gallium. And in case of n-type material we are using antimony, arsenic, or phosphorus. So if my material is of n-type, then I will be using phosphorus as impurity, and if my material is of p-type, then I will use the boron as impurity. Okay, keep in mind, same in concept in this one, drain also. Phosphorus, if I am adding phosphorus in silicon for what, n-type material, and if I want to go for the p-type material, then I have to go for the boron. and the gate is nothing but gate is connected by a polysilicon. This is the highly conductive material. That's why we are using the polysilicon. Normally silicon is there and polysilicon is the paste. I can say that is connected to the gate terminal over there. So how this NMOS and PMOS is constructed, that we will see. So NMOS, if you are observing this waveform, this diagram, so gate, the source and drain is there. So this is nothing but my drain is of N type metal, N type, and P type silicon is connected over there. So NMOS, in NMOS we are using P type substrate. The substrate, this is the substrate. So we are using the P type substrate. Then N type dopant for the source and drain. In the NMOS we are using N type dopant as it is NMOS, N enhancement MOSFET. So channel will be of N type region. It's okay. So this is nothing but N. So what we are doing? We are using the P type substrate in the NMOS, and the source and the drain is of N type over there. An inversion layer is formed to conduct the electric. So the inversion layer is of this one. You can observe the inversion layer is we are forming in this one by applying a negative voltage. If you are applying negative voltage, suppose this is my positive potential, so electron will get attracted at this range and they are forming one layer. So this is N type and this is again N type in the N type. The symbol of the NMOS is like this one. Symbol of NMOS is like this one without bubble. Keep in mind there is a difference in between these two, NMOS and PMOS. PMOS you will find a bubble, in NMOS you will not find any bubble. So remember like this one, P for bubble, and without bubble I will say like this one. So again the next MOS is nothing but my PMOS. So PMOS, the substrate is again N type. Okay, substrate is of N type and the P type dopant for source and P type drain. Okay, so the structure is reverse again. Structure is reverse. What is in the N channel? N channel. I'm sorry, NMOS itself. The substrate is of P type over there, and the channel is of N type material. Channel as well as the source and drain. Okay. Here PMOS, you have to remember like PMOS, the channel and the source and drain also P type, and substrate is of reverse. Substrate is of reverse. Like this one you can remember. For P channel, P type, PMOS, the substrate is of N type and the dopant and source and drain are of P type over there. Inversion layer is formed by conducting the electricity. So we are using the positive potential to conduct the electricity. Ah. So CMOS. So if you are combining these two structures, the NMOS and PMOS, if you are combining this structure, then what is the resultant is nothing but my CMOS. So here is nothing but my PMOS structure, and here is nothing but my NMOS structure. NMOS structure is there. If you are connecting like this one, this is nothing but my drain, this is nothing but my source, again this is my drain and source. If I am connecting the drain of first to the source of first to the drain of second, and I am taking output from this one, and this gate both are connected, then what will happen? The structure is called as what? Structure is called as what? Inverter. So what exactly inverter works? How it will inverter work? Inverter means 0 if you are giving the input, output is my 1. If you are giving 1 as input, output is a 0. So let's verify this. Let's verify it. So what will happen if you are giving a 0 at this terminal? If you are giving 0 as input, 0 as input, then what will happen? This PMOS will not turn on. Okay, if you are sorry, if you are giving 0 at this, so this complementary form, so what will happen? 0, this will turn on, this PMOS will turn on, so the VDD is passed to the out. That VDD is nothing but my 5 volt, that is nothing but 1. So 1 will pass when we are applying 0. Then if you are giving 1 as input, then what will happen? This is complementary, so this will not one on. The second transistor will turn on, this lower one, so this is VSS, that is ground, is connected to the output. So this will act as a switches. Keep in mind this is acted as switches. So how to remember? PMOS, if we are applying 1, 0 only, 0, then it will conduct. Whatever at a drain, it will pass. Okay, and in NMOS, if you are applying 1, then and then it will pass my whatever the uh, whatever I have connected at the source to the drain or drain to the source. Like this only it will come. So we have time. So this is nothing but my complementary MOS. So I will repeat this concept for you guys. So for PMOS, this is my PMOS. How to remember? The bubble is there. Okay, NMOS, the bubble is not there. So if for PMOS, if I am applying 0, then this will turn on. This will turn on. So for gate, it will act as a push switch. Okay, for 0, it will push and the VDD is connected to the output. Then if I am applying 1, then what will happen? The VSS is connected to the output also for NMOS circuit. So like this one you have to remember how PMOS 0 is there, it will conduct. For NMOS 1 is there, it will conduct. So like this one you have to remember, and the circuit is like this one. This is nothing but my inverter. The very basic structure of any MOSFET, any CMOS circuit. So the process flow, that is nothing but the structure is like this one. Okay, the PMOS and NMOS and all this are like this one. So how these are formed? How these are formed? So how to form? First the well is formed, N well or P well. Then isolation is formed, that is nothing but the isolation in between conducting and non-conducting. Okay, then transistor making is there, and interconnection is nothing but the transistor are interconnected to each other, that is nothing but the first transistor connects second, third to fourth to fifth, like this one the transistor are connected. So first well formation, then isolation formation, transistor making, and interconnection. So the fabrication process we'll see. So this is nothing but what we are doing, the well formation. So P side, you can see the what you can say side view of this one. So P substrate is taken over there. So start with the clean P substrate by P type vapor. We are taking the vapor over there, and this is nothing but my vapor over silicon. Okay. Vapor we are taking P side. Yeah. Then after taking the P type script, what we are doing, we are using SiO2. So SiO2 is nothing but what? It is silicon dioxide. It will form an isolation. Okay, because it is not conductive metal over there. So we are forming one layer of this. Okay. So what we are doing in this case? So here we are forming the well. Okay, well. So how to find the well? So by using photolithography process is there, and etching process is there. So what we are doing in this case, just a minute, I will explain this concept to you. So we are using one mask over there. So this portion I have to erase. Yes, I want to, I have to vanish over there from this portion. So what I will do, I will go for the mask itself. So I will take a mask from this. In the next slide I will explain. Okay, so this P substrate is there, SiO2 layer, and I will use the photoresist material over there. Okay, so photoresist material is there. So what we will do, photoresist material is, I want to go for this portion. I want to go for vanishing this portion. So the photoresist I will apply, then I will use mask. Okay, mask. In this one mask, this portion, whatever the portion, we know that from black portion the ultraviolet rays will not pass. So I will mask after this portion, after applying a photoresist material, to mask this portion as white and this portion as black. So what will happen if I am pushing to the ultraviolet, exposing to ultraviolet, this ultraviolet rays pass for this portion, and the remaining portion will like this one. But ultraviolet ray is, what you can say, expose this portion. If I am applying this portion, the etching process, then what will happen? Etching process. Then what will happen? This portion will vanish. This portion will vanish, and this form and what? Well. Okay. This is not a well. Next portion I will do. Well. So now I will, what I will do, I will bombard this by photon ion, phosphorus ion. So phosphorus ion P type substrate, phosphorus ions are there. That's why what we know, that phosphorus ion is nothing but my P type material, sorry, N type material. So this portion will form an, what you can say, N well. Okay, this form an N well, and this is coating of SiO2, so non-conducting. So this will not form any well. So this portion is open, so N well is formed. Okay, then well is formed. Then again from this portion, again I will use go for the thick SiO2 layer. So thick SiO2 layer, that's why what will happen, this will again, the portion will get this portion will get, what you can say, insulated or isolated, I will say isolated. Then Then what will do? I have to go for the NMOS. Okay, this is nothing but my PMOS will form over here. In NMOS, I will form over here. Okay, again the same process will carried out. Same process is carried out. Gate oxide. Same process is carried out in this case. Okay, so N all N there, the gate oxide are placed over there, and again I will go for the polysilicon. Why I am going for polysilicon? I have to connect the gate terminal because polysilicon is connected to the gate. Okay, polysilicon I have connected to the gate itself. Okay, so the N well, after that SiO2 layer is formed, then I will place the the polysilicon layer to form an gate. So after that, by etching process or photolytic process, photolytic process I have explained you, that is nothing but what you will do. I will apply a first photoresist material. After that I will go for the mask, and after that I will expose to the ultraviolet rays, and after that I will go for the etching process. In the etching process, whatever the portion I have applied uh, ultraviolet rays, that exposed to the ultraviolet ray, that portion will go, and whatever the non-exposed portion, that will remain as it is. So remaining portion I have go for the what you can say, unmasked portion, and this is the masked portion. So black portion is these two dots only. Okay, these two dots only. Remaining portion I have vanished over there. So the gate terminal is remaining. Okay. So I think we have to stop over here. In the next lecture we will go for the remaining process. Okay, next lecture we will go for the remaining process of this one. So I think I have to stop over here. So thank you very much for attending this lecture. Thank you.